Hello students, I am Subhashish. Have you ever wondered how a treasure map leads adventurers to hidden treasures? Or how does your GPS guide your family on a road trip to exciting destinations? Today, we are diving into the fascinating world of the section formula, a magical tool that let us divide distances in precise ratios. Imagine you are on a treasure hunt with your friends and you need to split the distance to your hidden treasure in a specific way. The section formula is like a map legend for real world coordinates, helping you calculate where you need to go. Whether you are planning a journey or cracking a mystery, this formula is your key to understanding proportions and ratios in the world around us. So, let's embark on this journey of discovery and learn how to navigate through real life scenarios using the section formula. Learning outcomes. At the end of this lesson, you will be able to understand the concept of the section formula for dividing line segments. Apply the section formula to find the coordinates of points internally dividing line segments. Identify conditions for using the section formula and solve related problems. Recognize the broader applications of the section formula in geometry and physics. Keywords from this lesson are section formula, ratio division, coordinate geometry, collinear points, centroid. Applications. We studied the bisection and trisection of a given line segment. These are only particular cases of the general problem of dividing a line segment joining 2 points x1, y1 and x2, y2 in the ratio m:(n). Given a segment AB and a positive real number r, we wish to find the coordinate of point P which divides AB in the ratio r:1. This means AP by PB is equal to R by 1 or AP is equal to R into PB. This means that x minus x1 is equal to R into x2 minus x. Solving this, we get x equal to rx2 plus x1 by r plus 1. Consider it as equation 1. We can use this result for points on a line to the general case as follows. Taking AP is to PB is equal to R is to 1. We get A dash P dash is to P dash B dash is equal to R is to 1. Therefore, A dash P dash is equal to R into P dash B dash. Thus, x minus x1 is equal to R into x2 minus x. Which gives x is equal to R into x2 plus x1 by R plus 1. Precisely in the same way, we can have y is equal to R into y2 plus y1 by R plus 1. If P is between A and B and AP by PB is equal to R, then we have the formula P is Rx2 plus x1 by R plus 1 comma Ry2 plus y1 by R plus 1. If R is taken as m by n, then the section formula is mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, which is the standard form. Let us see one example. Find the coordinates of the point which divides the line segment joining the points 3, 5 and 8, minus 10 internally in the ratio 3 is to 2. Solution. Let A 3, 5 and B 8, minus 10 be the given points, and let point P x, y divide the line segment AB internally in the ratio 3 is to 2. By section formula, P of x, y is equal to P into mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus 1. Here x1 is equal to 3, y1 is equal to 5, x2 is equal to 8, y2 is equal to minus 10 and m is equal to 3, n is equal to 2. Now substitute all the values in the formula. Therefore, P of x, y is equal to P of 3 into 8 plus 2 into 3 by 3 plus 2, comma 3 into minus 10 plus 2 into 5 by 3 plus 2. By multiplying them, Now by multiplying we get P of 24 plus 6 by 5 comma minus 30 plus 10 by 5. So by solving we get P of 6 comma minus 4. Therefore, P of x comma y is equal to P of 6 comma minus 4. Let us see another example. In what ratio does the point P of minus 2 comma 4 divide the line segment joining the points A minus 3 comma 6 and B 1 comma minus 2 internally? Solution. Given points are A minus 3 comma 6 and B 1 comma minus 2. P minus 2 comma 4 divide AB internally in the ratio m is to n. By section formula, P of x comma y is equal to P of mx2 plus nx1 by m plus n comma my2 plus ny1 by m plus n is equal to P of minus 2 comma 4. Here x1 is equal to minus 3, y1 is equal to 6, x2 is equal to 1, y2 is equal to minus 2. P of m of 1 plus n of minus 3 by m plus n comma m of minus 2 plus n of 6 by m plus n is equal to P of minus 2 comma 4. Equating x coordinates, we get m minus 3n by m plus n is equal to minus 2. Or m minus 3n is equal to minus 2m minus 2n. Take all m terms to one side and n terms to another side. We get 3m is equal to n. So m by n is equal to 1 by 3. M is to n is equal to 1 is to 3. Hence, P divides AB internally in the ratio 1:3. Let us see one more example. What are the coordinates of B if point P minus 2, 3 divides the line segment joining A minus 3, 5 and B internally in the ratio 1:6? Solution. Let A minus 3, 5 and B x2, y2 be the given 2 points. Given P minus 2, 3 divides AB internally in the ratio 1:6. By section formula, P of mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n is equal to P of minus 2, 3. Now substitute all the values in the formula. We get P of 1x2 plus 6 into minus 3 by 1 plus 6, comma 1 into y2 plus 6 into 5 by 1 plus 6 is equal to P of minus 2, 3. Equating the coordinates, we get x2 minus 18 by 7 is equal to minus 2. x2 minus 18 is equal to minus 14. x2 is equal to 4. Similarly, y2 plus 30 by 7 is equal to 3. y2 plus 30 is equal to 21. y2 is equal to minus 9. Therefore, the coordinate of B is 4, minus 9. Summary of the lesson. The section formula allows us to divide a line segment between points x1, y1 and x2, y2 in the ratio of m:n. If ratio r is equal to m by n, then the section formula is mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, which is the standard form. For internal division, the formula for x coordinate is equal to mx2 plus nx1 by m plus n, and for y coordinate my2 plus ny1 by m plus n. The section formula is valid only when the points are collinear along a straight line. Thanks for watching.